And then the question that comes is, so how are we gonna read this data? So that's kind of like a design decision. So if we had like these 4 bytes, and I'm looking at this, we say, okay, the address 0. Am I gonna read it like this way, or am I gonna read it that way? So it sounds trivial. Like to me, I would say, okay, I'm gonna go from here, but it's not something that everyone agreed on. And actually, we have 2 different systems. So here, we call this endian. So little versus big endian, or endianness of a processor. So basically, this means the byte ordering. So what is the direction that we are ordering these bytes into, that 4 bytes that are grouped together? So that's the idea of big endian and little endian. So in big endian, the most significant byte is at the lower address, and the least significant byte is at the higher address. So most significant is at lower, least goes as higher. So little endian is the opposite. Most significant is at higher address. So let's look at example. So here, let's say we have a number, right? Or this variable has 4 bytes of data. And this is the pattern actually that the variable is. So if this was a number, for example, this is the layout that we have. So which one is most significant here? Which one is more significant? B3, right? B3 is a higher significant because it's to the left, right? So imagine if you have 1110. So that one to the left of the 1000, that's the most significance, right? So this is the most significance. And here in big endian, we are saying that the most significant is at the lower address. So if you look at here, these are our address pattern. So n plus 1, so that's our address. So the lower address is this n. And we said big endian is at the lower address. So this B3 is appearing here. And then B2, and then B1, and then B0. Little endian is the opposite. Here we have an example. On the right side here, we are seeing basically the memory pattern, and we are looking at it as the byte level. So we are looking very closely, right? So if you look at the addresses, you see 8, 9, AB. So it's byte level, and each of these is 1 byte, right? So I'm gonna talk about this. If you don't understand it right now, we gonna like introduce this whole concept of these like registers, which is like the then numbers followed by these dollar signs, and these instructions later in the course. I think in maybe by end of this slide deck or next one. So you can always come back and look at this. But basically, what this instruction is doing is reading something from the memory. So this is your memory, and you have 2 variables here. So think of this as variables, this 16 and 17 with the dollar sign. So in the $17, in this variable, you have this address. So that's the address. And how this works is going to read from this address that is specified here and load the content and save it here. So that's basically what this is doing. It's going to read the content from this address that is given here, which is that, and load the content and save it here in 16. So here you see that the address that is given is this 1001.0008. So that's the address. But this is a load word. So we have load byte and we have load word also. So this is actually loading a word which is 4 bytes. So it's going to load all these data. So the question is here is basically, if we are in a little endian or a big endian system, what is going to be the content of register 16 after running this line of code? So that is the question here. And we have to look back to the definition, right? So in big endian, the most significant byte is at the lower address. So let's do this one first. The most significant byte is at the lower address. So what is our lower address here? our lower address. So first of all, to make this very clear, this load word is loading this address, right? And I said it's loading 4 bytes. So the addresses that it's gonna be load or read from, it's gonna be this with 8, 9, A, which is 10, or B, which is 11. So that's the 4 addresses that it's gonna load. So 8, 9, 10, 11. It's gonna read the content from here. So that's what we are loading. But the question is which order we are going. So here it says the big endian, the most significant byte is at the lower address. So in this 4, which one is our lower address? It's actually this 8. So that is gonna be our most significant. So that means our number gonna be, in big endian, you see it's starting with 9, 9, and then the next one, AA, BB, CC. So we are going this direction. That's our number. If it was a little endian system, the most significant is at the higher address. So this is our higher address. So we know our number is actually CCBBAA99. So that's the difference between these two systems. So here we have a C code that basically you can detect if your system is running on little endian or big endian. So what is the memory pattern that it has? And take a look and try to understand it. If you are interested, I can make a separate video and actually like run this and try to explain like what is going on this. But you can do some as a kind of like extra thing, or maybe I post a link about that. So here let's look at, again, we are back to the 32 bits. So we see here 048. Let's try to guess these answers here. So if you are looking at the content of the byte, so we are looking for 1 byte of that is located in this address. And we are also going like this direction. So this is going to be the first one, second one, third one, and so forth. So what is the byte address in this address? It's going to be the first one here. So it's going to be 13. So that is the 1 byte. What is the byte? Well, I shouldn't have. What is a byte at 02? So this is 00. These two are 01, and then these two are 02. So 5, 7. And again, each 2 digits is 1 byte, right? This is hex. In hex, we had each digit is 4. So if we have two digits, that's gonna be basically 8 bits, and 8 bit is 1 byte. So like to summarize, each 2 of these is 1 byte. So when you are going at byte 2, this is your byte 0 because of this address. This is your byte 1 here, and then this is your byte 2. What is the byte of content of the address 04? 1 byte. So we are looking at this 9A. That's the first one. What is the content of 07? So this is 4, these two are 5, these two are 6, then these two are 7, so EF. And what do we have? Now this time is asking for a word. So word was 4 byte as address 4. So 4 bytes from here. So 1, 2, 3, 4. So that's going to be the whole thing here.